Hi, I'm Larry Huppin. I'm a medical consultant at ProLab Orthotics, and over the next few minutes we are going to look at the most effective ways to integrate foot scanning technology for orthotic devices into your practice. Our goals here are to review the evidence-based criteria for functional orthotic imaging or casting, to introduce ProLab's digital foot scanner. We're going to compare scanning versus casting, and then we're going to look at how to best implement scanner into your practice. So I think the first question you must ask is how to capture the foot to get the best possible foot orthosis. And when I say best possible, basically the one that's going to give you the best potential clinical outcomes. So here are these casting criteria based on the best evidence. One, the foot image should be captured in a non-weight bearing subtalar joint neutral position. The first ray should be plantar flexed to the end of its range of motion during the casting or scanning process. The posterior heel must be captured to allow frontal plane correction of the orthosis. And the image must obtain a precise 3D representation of the plantar aspect of the foot. Now, for more information on the evidence we looked at, you can request this white paper from ProLab. We go over all the evidence that is currently available on the most effective methods to take an image of the foot in order to create a custom orthotic device. So there's several techniques that do meet this evidence-based criteria. The first of those, of course, is just simply plaster casting. It's still an excellent way to get an image of the foot. Not necessarily the most efficient way, but certainly clinically very effective. The STS sock, something that I used for a number of years prior to scanning. And then there are digital scanners available. Now that I think it's very important to note that not all digital scanners meet this criteria, but some of them do. So this is the ProLab digital scanner. What we like about this unit is it does meet those evidence-based criteria. It does capture a true non-weight bearing 3D image of the foot. Takes less than 5 seconds per foot to scan. The software itself is very intuitive and easy to use. It's overall portable, has a good support infrastructure, and it's consistent. It's just a very accurate device, essentially the same as casting. Matter of fact, exactly the same as negative casting. This is the positioning of the foot. You're going to do a non-weight bearing cast. We can see here we plantar flexed first ray a bit. This is exactly the same as you might position the foot for a plaster cast. Here's taking the image itself. You can see it only takes a few seconds to get that image. And then you're able to evaluate the foot in several different positions. This is a black and white image just to make sure that it's in the longitudinal axis. We see a topographic map. And finally, you also have the ability to look at this in 3 dimensions, just as if you were looking at a negative plaster cast. So here's that 3D view. We can look at that in any position we want. We can also look at it directly from the rear and use that T-bar to ensure we do have a correct forefoot to rear foot relationship. So I think there are several advantages to scanning, depending obviously on the scanner, but the correct scanner, there are clinical advantages, there are certainly advantages in efficiency and significant cost advantages also. So let's look initially at the clinical advantages. First, it does accurately capture a 3D image of the foot in a standard subtalar joint neutral position. That's also true of plaster casting, but in many ways this helps eliminate suboptimal cast. At ProLab, we certainly see better images coming through from those people using the scanner overall than we do with plaster casting, and that's for several reasons. Number one is that the doctor can take all images. We find that in situations where plaster is being used, often this is delegated to staff, and the reality is when staff is taking the image or the cast, it tends not to be as good as when the doctor is taking that image. The casting or the scanning is so quick, it's very efficient, it's just much more likely the doctor is going to take that image. It is one person operation. You can quickly redo poor images with no added cost. And that's not necessarily true of plaster. There's not only material cost, but significant time cost in redoing the cast. And we find that people are less likely to do so. With the imaging, it's so quick and to take that second image, and there's no cost involved at all, that you're much more likely to redo a poor image. There's less chance of the foot moving. That's particularly important in children, and that's simply because it's so much faster to get that image. No damage in removing the cast from the foot with scanning, and you can capture bony prominences as easily as you can with plaster. No potential shipping damage to the cast, and again, you can get the highest quality orthosis just as you can with plaster. Okay, some of the efficiency advantages. And number one is just dramatic improvements in patient flow. The patient is in and out of the treatment room much faster. Not only is the scanning much faster than plaster casting, but there's no cleanup, and so it's very easy to take that image on the day the patient presents for a first visit, for example, rather than having them come back on a separate day. The visits, if they are coming back for a separate casting visit, those visits tend to be much faster. You can easily move it from room to room, so you can cast in multiple rooms. You don't have to have one room set aside. That certainly also improves efficiency and flow in the office. And in general, I think you can see more patients per day because of that. You don't need to store cast while they're drying, so it saves some space. There's no packing the cast for shipping. That certainly saves a lot of employee time. And you also have improved turnaround time because you can get the images to the lab via email that same day. You don't have to wait for them to be shipped down. Some of the cost advantages. Number one is decreased staff and doctor time for casting and for cleanup. This is by far the greatest time and certainly cost advantage. There's obviously, for staff, there's no packing and shipping a cast, there's no cleanup time, there's no per patient materials cost as there is with plaster cast. Better use of the rooms. You don't have to set aside a dirty room just for casting. It enables increased patient volume, and there's a marketing advantage. You look high tech, and there is an appreciation, I think, among many patients for that. A study in 2007 by Craig Payne, an Australian podiatrist, looked at time motion for casting versus scanning, and found that for plaster cast, it's about 11 to 16 minutes to get the image in, or get the cast and get the patient in and out of the room, and with digital scanning, average about 2 minutes. Cost came out to, in these Australian dollars, $37 to $49 for plaster cast, digital scanning $5 to $10, and again, a lot of that is just in the doctor time. He was assuming a doctor value of, I believe, $150 and staff time of about $25 an hour. We do have a spreadsheet available if you're interested on the cost savings. You can just request that. We can provide it for you. Now, based on the doctor at $150 and assistant at $25 an hour, if you're doing 5 pair of orthoses a month, you're going to see an annual savings of about $2,400, and if you're doing 25 a month, you'll see an annual savings of about $12,000. Now, let's look at some of the considerations for integrating a scanner into your practice. We're going to look at IT requirements, training, managing the files, and HIPAA. The computer scanner can be provided for you as a unit. We can bundle those together and have everything loaded for you. It certainly makes it easy for setup, although setup's not that difficult regardless. It's a standard USB connection between the scanner and the computer. Internet access is simply necessary for emailing the images to the lab. And you can actually, even if that particular computer doesn't have internet access, you can just use a thumb drive to move those images to a different computer and then email them from there. If you'd rather, by the way, if you'd rather use your own computer, you can certainly do that too and save some initial cost on the setup or on the bundle. The hardware setup is very quick. It probably takes 10 minutes or less to get the unit set up. And there's videos and a step-by-step manual provided to help you along with that. ProLab will provide in addition significant training. We'll do an online or in-person training session about 30 to 60 minutes. But again, the software is extremely user-friendly and easy to learn. We also have manuals available, and we're always available to walk you through any issues that you might have. We do ask everyone to take 30 to 50 practice scans prior to sending the first patient scan to the lab. But again, it takes 4 seconds per foot. So you can easily do 30 to 50 practice scans in about 30 minutes. So it becomes very, very easy to get trained on this scanner. We will initially evaluate your scans and let you know when it's safe to go ahead and send in a patient scan. So the package includes a scanner, the laptop. It includes training and user manuals, includes training sessions as necessary, and ongoing clinical and technical support. We can also log into your computer if there's any issues. And again, if you want to provide your own laptop, you can do that also. I think it's worth mentioning this other scanner that is on the market, the iPad structure scanner. It's actually, in some ways, it's a nice idea, and that tends to be a much more portable device. This is the structure scanner. It is used by many labs under different names, but it's all, anybody that's using an iPad for getting an image of the foot, this is what they are using. The problem I have, by the way, before I say that, it's actually a very nice image. It's a true 3D image of the foot that is made by this device, but here's the downside. It is much less efficient because it does require 2 people to get an accurate image. If you're going to position the foot correctly, you really need someone to position the foot and someone else to hold the iPad and take the scanner. Another option is you have this actually effective but somewhat cumbersome foot positioner that will help hold the foot in neutral and even plantar flex the first ray. The problem is time involved here. So to position the foot and then get the image, and to get the image you have to move this iPad around the foot. It probably takes about 90 seconds if you're using the positioner, and 30 to 60 seconds if you have a second person holding the foot. So you're either taking significant amount more time, or you're having to have a second employee available in order to get the image. So although it's a nice unit and does make a nice image of the foot, it's a much less efficient method. And although it's a little less expensive up front, over time, just because of doctor and staff time, it becomes much more expensive also. So the summary here is that the ProLab digital scanner will provide the same quality image and evidence-based foot capture as plaster casting. It offers a number of clinical efficiency and cost advantages over casting, and the package and our team at ProLab really can make it very simple for you to implement this type of digital technology in your practice. Bottom line, you really don't have to compromise your orthotic quality at all in order to get a much more efficient process in producing these devices. Any questions, please contact us at either by email at this email address or at 800-477-6522. Thanks for your time.